Now let's follow the textbook. Okay, ignore this page. It's not something really important. Here are some question. I think it's better to do it a little bit to warm up your brain. Okay, let's continue. Hello, bye bye. So now we have to learn the laws of exponents. So here's three formula. Oi, good job. Here's three formula. Now I will prove this three formula. It's better for everyone to remember it. If you know how to prove it, you don't have to remember it, or you can remember it more faster. Jesus. So okay, for first formula here, a to the power of m times a to the power of n is equal a to the power of m plus n. Why? We can expand these three exponents. According to the definition, a to the power of m, it means m amount of x time together. A to same a to the power of n, it means n amount of a time together. So these two time together, here will be m plus n amount of a multiplied together. So that's why it's equal. Okay, I will not really write to expand it. And for it's same that here's something like that. A to the power of m divided by a to the power of n is equal a to the power of m minus n. Jesus, m. It's same because how do you say that? On the top, a to the power of m, it means m amount of a multiplied together. At bottom, it means n amount of a multiplied together. So because for divide, we have some rule like that. If bottom and top have same term, and the relationship between every term is time, then you can make them disappear. So for them it's same. Here, if imagine that here's if m is more than n, it means here will be more a than bottom. So here will be n amount of a disappear for both bottom and top. So left it will be only m minus n amount of a multiplied together. So it's like that. But maybe you guys will ask, so if it's like that, how can you explain if m is less than n or equal than n? Yeah, I will explain it later. Never mind. Don't worry. So the last rule is a to the power of m to the power of n is equal a to the power of m times n. Also, it's easy to understand. So let's expand this first. So it means here's n amount of a to the power of m time together. So it will be something like and at the end we can also expand this. Here will be one m amount of a multiplied together. There's this two time together. According to this one, we know that here will be a to the power. Okay, it's equal a to the power of 2m. It will be a to the power of 3m. So we will have n amount of a to the power of m. So the total it will be a to the power of n times m, because here's n amount of a to the power of m multiplied together. So yeah, so it's like that. So it is just three rule. It's basic laws of exponents. Okay. Oh my god, it's first time I record myself to teach something. So, I will improve my English. Okay. Now, here's another key point. It's something like that. A to the power of negative n is equal 1 divided by a to the power of n. Why it's something like that? Now I will explain why we can accept if m is less than n, because I mean according to the original definition, the power only can be a positive integer. So the only exponent we can calculate, the result is discrete. Okay, this word discrete. So because I mean before, I think everyone learned function. So actually if you learn function, we know that we have a graph for I mean we can put all the real number or many real number in the function, so we can get output. But for the original exponent, the power only can be positive integers, so it's discrete. So I forget who. Euler make exponent can also work for decimal, for rational number, even irrational number, odd real number, even complex number. So Euler make exponent from discrete to continuous. Okay, good job. So how did wait. How did Euler solve it? So Euler do something like that. So for example, the power only can be positive integer. So the first thing Euler solved is if the power is equal 0. So how can we let here equal 0? We can find something here. M here is m minus n. Why we use this formula? Because if originally m and n only can be positive integer, the result of m plus n is also a positive number. So but only here we have minus. Minus we can make the power equal 0, even negative. So Euler do something like that. A to the power of 0 is equal a to the power of m divided by a to the power of m. Okay, just imagine that here m is more than 0 and m is an integer, positive integer. According to the formula, we know that it's equal to this, so it's a to the power of 0. Okay, never mind here. But we also know that because a to the power of m is equal a to the power of n, so the result here will be 1. So we know that a to the power of 0 is equal 1. But be careful, a could not be 0. Why? Because 0 to the power of anything is equal 0, and 0 divided by 0, in real number, here's no result. Yes, so here's a condition that a cannot be 0. Then let's continue. If we want to let power as a negative integer, we just let here but top m less than n, which is like, for example, a to the power of 2 or a to the power of 4 is equal, here's 2a, here's 4a times together, so it's a squared 1 over 1 divided by a squared, and And also according to the formula, we know that is equal a to the power of -2. So these two equal together. Okay, so actually this step is called analytical extension. This word is from it's from a math course called complex function. Like in university, if you learn something related to computer science, math or physics, you have to learn complex function. So in complex function, it's like to make a functions to extend functions domain to let more number make more number valuable to put. Oh my god, how do you create this sentence? Make more values. Oh my god. Yes, make domain bigger to. Oh my god. Oh my god, let's skip it. So basically is like to make more input also makes sense. Yeah, because at the begin, if we put 0 negative integer as an exponent, it's not make sense. So we just use this formula to extend the domain. Then we can also extend the range of this kind of operation. Okay, ignore my English. Yes. So it is the formula we have on the book. Let's continue. And here we have this two formula. It's also easy to remember. Also easy to prove because a times b, oh my god, a times b to the power of n is like n amount of ab multiplied together, right? And because here's time between every term, so we can break the bracket. So we can break the bracket, then rearrange. No. Oh no. We can break the bracket and reorder the order of everything. So after we reordered, it will be like something like that. Here will be n amount of a timed together. Here we can put a bracket time b amount n amount of b multiplied together. So it's equal a to the power of n times b to the power of n. And for the second formula, we can use same method, but the relationship between a and b is divided by. So, but yes, I think everyone can try to prove it by yourself. So here is some example question. Okay, let's find who is loser. Okay, be an examiner. Everyone can try to be an examiner and to judge which two students are loser. Let's check. So as the formula we have it here, if we expand a bracket with exponent, we should like let this power to everything, like so 2 to the power of 4, x squared to the power of 4, y cubed to the power of 4. The result absolutely is wrong because a to the power of b to the power of c is equal a to the power of b times c. So 2 times, it should be 2 times 4, it should be 8. It should be 3 times 4, which is equal 12. So solution 1, the student 1 is a loser, he cannot go to university. And the solution 2, let's check. It's correct. No, not really correct, because 2 to the power of 4 is equal 16. I don't know why he timed 2 and 4 together, so it's wrong. Loser. Then solution 3 absolutely is correct, because here, if they ask you which one is correct, it means it must be one correct solution. So here is correct. Let's clap for the student 3. Okay, let's go. Actually, I wanna talk about this question. Express 3 to the power of 4 times 9 to the power of 5 in the form 3 to the power of k. So the thing is, the things we need is the base of the thing we need is 3, and this thing here 3 to the power of 4, the base is 3, but 9 to the power of 5, the base is 9. But no worries, because 9 can write as 3 to the power of 2, 3 square. So we can rewrite everything as they said. Write 9 as 3 squared and put it in with bracket. Then according to the rule, we can expand it. Then get k is equal 14, like that. Oh, and here is equation. So we have same method. The base of left side is 2, and the base of right side is 8. So we can write 8 as 3 to the power of 3. So here, guys, we remember this method. It's really useful. Also, it shows something. Because maybe everyone will think, if for example, a plus c is equal b plus c, so a is equal b. A times c is equal b times c, so a will equal b if c is not equal 0. So everyone will think, if for both sides, for a and b, if for a and b we do same calculation, the result we get is still equal, so it means a is equal b. It's like, if a plus c equal b plus c, so a equal b. If a times c is equal b times c, so a equal b if c is not 0. So maybe everyone will think, oh, if, for example, if 3 to the power of a is equal 3 to the power of b, so it means a equal b. So everyone will think, if for number a and b, if we do same operation, the result of left and right side is still equal, it means we can prove a equal b. But not every time we can do it. For example, actually, we know that if x equal y, obviously both sides is equal, but it not means if x to the power of x equal y to the power of y, then we can prove x equal y. Because, for example, everyone can use calculator to calculate this. This two is equal, but obviously half and quarter is not equal. So it shows that exponent, the result of exponent is the only, or okay, I don't know how to describe it, but it's like, so it's a special property of exponents. So we will face many problems which need this property of exponents, then we can solve some equation. Yes, let's continue. So, I mean, everyone can... Oh, I think everyone received those paper, right? Received this question. So, I think this question is... Okay, it's not just easy, but I would say everyone can just do it. For example, when you're on the plane, you take a photo of those questions, then you just do it. Maybe when you're in the plane, in the train, you just take some empty paper and just write something. Yeah, try to do this question. I think. Okay, do this question, and especially from 40 to 43. I want to see this. Oh, from 36 to 43. After you guys finish it, take a photo, send it in the group chat. I will see. Good job. And for this thing, operation with numbers in the form a times 10 to the power of k, where a more or equal 1 and less than 10. And k is an integer. So for this knowledge, I remember at the beginning of this year when I was in Miss Blue's class, I remember this course. So I mean, it's easy to change it, to change a number to this form, but I wanna introduce an easy way to make everything faster. Okay, it is my experience. Okay, for example, 114,514. How do you write the result really fast? Okay, you just count. It is first how do you say that? First bit. First digit. Yes, first digit. So let's count. 1, 2, 3, 4, 5. So 10 to the power of f. 10 to the power of 5. Then 114,514. Here's a dot. Just imagine that here's a dot. So it's 1.14514. Then it's the result. And for like decimal is like, for example, 0.19198101. For this, okay, this one is easy, so I will show this. 0.0000521. So how to make this one faster? So for this case, the thing we count is not like that. Not except first digit, how many digits do we have? For this one, we should count how much zero do we have in front of the first digit, which is not zero. For example, in this case, it will be 5. 5 is not zero, it's first digit, which is not zero. Then count 1, 2, 3, 4, 5, 6. 10 to the power of -6. Then 5, 2, 1. Here's a dot. Yes, it is oh my god, it's the fastest way to find the exponent. I remember it's my Chinese math teacher taught me that. It's really fun. Yes, math is really fun, guys. I mean, after you learn more math, you'll find, oh, math is amazing. Okay, never mind. So also I want to explain why if we use this form is why most of the time we use this form, because it's easy to time or divide them. For example, this case, you see, because we have like common exponents, then we can just time them together according to the law we learned. And for here, because the number here is all more than 1 and less than 10, so if the number, the decimal is not, the digit is not too much, I mean after the dot if it's not too much, when you time them together, it will be faster. It's convenient. For example, in this case, 3 times 4. 3, 4? 3, 4 equal 12. So we know it's 12 times 10 to the power of 7 minus 3. 7 plus minus negative 3. So it's 10 to the power of 4. But remember, because this form, a must be more than 1 and less than 10. So because 12 can write as 1.2 times 10. So here, this step is like that. That's why we have to change 12 to 1.2, because it's a thing we need. And here's the example question. To prove that you just show your step. For here, remember the formula. A to the power of negative n is equal 1 divided by a to the power of n. So we use this to change it to like that. Then we calculate to show the result. So it's everything related to the exponents. Okay, I don't know. Can everyone understand it? If you guys have a question, just tell me. And I mean, I still have to improve my English. That's the thing I know. I mean, if I can teach everyone face to face, it will be better. But oh my god, now I have no idea. Okay.